In our final example, we are going to use Desmos to graph a piecewise function. Desmos is a useful tool because it can allow us to quickly and easily adjust the domain to meet the needs of a particular piecewise. To get started, I have the graphs of three different functions: y equals x squared, your parent parabola, y equals negative x, and y equals x, two lines with slopes of -1 and 1 that travel through the origin. Obviously, if I was to consider all three of these at the same time, this is not a function. We have significant overlap between all of them. We've got intersection points in lots of different places. So what we'd like to do instead is restrict the domain of each one of them and create a piecewise function that we can analyze. Now, creating a piecewise function in Desmos is more of a challenge of typing than anything else. When we want to create a piecewise, we want to make sure we are using set notation. So we open up a brace, and I'm going to restrict the parabola to be x is less than 0. So we're going to say x is less than 0 and close the brace. And you can see that I now only have the half parabola. Same thing for y equals negative x, but this one we're going to stay between 0 and 1. So we're going to say x is less than or equal to, x is greater than or equal to 0, but also that x is less than or equal to 1. And you can see that my blue graph, my y equals negative x, is restricted to this tiny space here when it was that entire line. And for the last one, we'll go x is greater than 1 and finish the graph. So I went from this non-function, three graphs on the same coordinate system, to now this very neat and orderly function. It is worth zooming in on the two breaking points in the graph, the 0 and the 1. So if I look at those two locations, you'll notice that based on the way that I've chosen them, and based on the way that the three graphs interact, you'll notice that at 0, the parabola actually meets the line. So truthfully, it would not matter where I would put that equal to. I could put the equal to on the y equals x squared, or I could put the equal to where it is with the y equals negative x. Either way, this thing is traveling through the point 0, 0, regardless of its assignment. In that situation, you have what's called a continuous function. A continuous function is where the two different parts of a piecewise function meet. Now, continuous is going to have slightly different definitions along the way in all of your study of math. When you get to calculus, continuous means a lot of important information. Continuity gives a lot of important information for us. But for right now, we're just recognizing the fact that those two parts of the piecewise are meeting. Contrast that to what's happening over at 1. Over at 1, I have this location up here and this location down here that very obviously are not meeting. In this spot, we have what's called a discontinuity. There's a break in the piecewise function where the two parts don't meet. And in particular, this is referred to as a jump discontinuity, where the function appears to jump from one spot to another. Now, the one thing you'll notice about Desmos, and we mentioned this in a previous video, and you're going to see it on the calculator, the regular TI calculators as well, is that Desmos does a bad job of showing where the actual point is. You can't see it where that point is at 1. It really should be down here because this is where the equal to is. There should be a little bit more of a defined space there. However, it doesn't show it. So you need to be careful when you're using some kind of graphic technology to be sure that you are understanding that that's where that point should be. In the event that you're not sure, you can follow along the curve, and you see how there's a 1, -1 there. That point exists. And if I follow the green one down to the end, I get the undefined. So while it'll show it to me if I click on it, it does not show it to me in the picture right away. I have to be a little bit careful when I'm looking for where that point should be on each part of the piecewise.